Every day, tons of textile waste arrive at the facility. These compressed bales contain discarded garments and fabric scraps. The first critical step is sorting the fabrics by material composition. All non-textile items like zippers and buttons must be removed. Once cleaned, the fabric is ready for the grinding process.
This mixture of cotton, polyester, and wool creates the base blend.
The shredding process begins to break down the textile structure.
Powerful steel blades rip the textiles into coarse shreds. The output is a mass of shredded fabric known as rag. Dust extraction systems simultaneously remove fine particles. Vibrating screens filter out any remaining debris or oversized pieces. Consistency and size is key for the next stage. Now, the coarse rags enter the fiber opener. These cylinders work to individualize the fiber strands. The shreds are pulled apart until they revert to loose fiber form. This regenerated fiber is stored and ready for blending. The mechanical recycling process is now complete. Quality checks ensure the fiber length is suitable for insulation. The fibers are pneumatically transported to the mixing unit. To achieve uniform color, fibers from different batches are blended. A small percentage of bonding fiber is added for strength. This ensures the final insulation product has consistent density. The homogeneous blend is now fed into the carding machine. Carding aligns the fibers in a parallel orientation. A thin, uniform web begins to form on the surface.
This web is still fragile and requires layering.
A crosslapper folds the web to build up the desired weight. This creates a multi-layered bat with cross-directional strength. The bat now looks like a thick, uniform blanket of wool. Pre-compaction removes excess air before bonding. Next, the bat enters the needle punching zone for mechanical bonding. Thousands of barbed needles penetrate the fabric vertically. The barbs entangle the fibers, locking them together. This friction and entanglement provide structural integrity. The loose fibers are now transformed into a solid fabric. A second pass refines the surface texture. The result is a durable felt-like material. The material is now ready for thermal bonding. To set the dimensions, the fabric enters a thermal bonding oven. Hot air activates the low-melt fibers added earlier. These melted points act as glue, solidifying the structure. After cooling, the insulation achieves its final stability. Rapid cooling locks the bond in place instantly. Automated sensors scan the fabric for thickness consistency. Any deviations are detected and corrected automatically. Rotary cutters trim the edges to ensure a uniform width.
Edge trims are captured and fed back into the process. The continuous roll is now cut into specific lengths. Heavy-duty crosscutters slice the material to size.
These sheets are stacked for packaging.
Automated arms wrap the stacks in protective plastic.
Heat sealing ensures the product stays dry and clean.
Finished pallets are moved to the shipping warehouse.
This insulation is destined for construction sites.
Labeling provides thermal resistance and product specs.
The factory operates continuously to meet demand.
Final quality assurance guarantees performance standards.
Products are compressed to optimize shipping logistics. On site, the insulation is unrolled between wall studs.
It provides excellent thermal and acoustic insulation.
Old textiles are given a new, valuable life.
The trapped air pockets are key to thermal resistance. Advanced control systems monitor the entire production line.
Precision engineering drives the recycling efficiency.
Air filtration systems maintain a safe environment. High-torque motors power the heavy shredding tasks.
Regular maintenance ensures continuous operation.
Denim is a popular material for blue insulation products.
The original color often remains, adding character.
Synthetic fibers are blended to enhance resilience.
The blend ratio determines the softness and R value.
Each roll is weighed to verify density.
Accurate weight ensures consistent thermal performance. Some specialized items are still handled by hand.
The texture is similar to natural wool felt. It has excellent recovery and compression resistance.
needle punching process is entirely mechanical.
No chemical binders are required, making it eco-friendly.
The fiber opener is the heart of the textile recycling line.
It efficiently reduces waste volume significantly.
Automated conveyors minimize manual handling.
Powerful magnets catch any missed metal contaminants.
This protects the machinery from damage. Only pure textile fiber proceeds to the garnet. Some fiber is sold as raw material for other industries. Hydraulic presses create dense bales for transport. These bales are shipped to spinning mills or fill factories.
The versatility of recycled fiber is vast. Pieces are stacked according to order requirements.
Tracking labels ensure full traceability of the product.
Workers verify the label matches the batch number.
Shrink wrapping protects the insulation from moisture.
A tight seal is crucial for storage conditions.
Sensors help navigate the factory floor safely. The loading dock is the final stop before dispatch. Trucks distribute the insulation to hardware stores. A sustainable solution for textile waste. This factory helps reduce the environmental impact. Closing the loop on the circular economy. Every day, more waste is transformed using state-of-the-art recycling technology. Providing green building materials for the future.
The beauty of regenerated fiber.
Dedicated to quality and sustainability. A complex process turned into a seamless flow.
Shredding.
Fiber opening. Needle punching. Cutting and packaging.